Can everybody hear me through the speakers? Okay. Thank you, everybody, for coming to attend this talk. My name is Iqbal Khan. I am a technology evangelist at this company called Alachisoft, and we're actually changing its name because everybody keeps telling us it's very hard to pronounce. So we're going to call it NCache Labs. NCache is what we're known by, and everybody calls us NCache folks, so we're going to change it to NCache Labs. Here's a brief, just a little bit of marketing about our company. It's a software company based in San Francisco Bay Area. I'm based in Tampa. NCache is our in-memory distributed cache. NOSDB is a NoSQL JSON document database that we've launched last year. It's starting to get a lot of traction. It's like a MongoDB, open source, but native.NET. Take a look at it. Okay. So I prefer to have a more interactive discussion. So as I'm talking, if you guys have any questions, please raise your hand so we can talk about that specific question that you might have. Or if there's something that I'm not making sense, or if you don't agree with, please do raise your hand. Okay. Let's first get some definitions out of the way. You probably know these already, but just for completeness purposes. What is scalability? Scalability is not application performance. It's not about fast applications. If you have an application that has super fast performance with 5 users, you're not scalable unless you have that same performance with 5,000 or 50,000 or 500,000 users. So scalability is high performance under peak loads. If you have performance issues with 5 users, then you need to attend some of those code talks. I'm assuming that you have done a good job and your application performs well, but you just are not able to scale for a variety of reasons. Linear scalability essentially means that if your application is architected in a way where you can add servers, and by adding a server, you get a linear increment in the number of transactions that you can process through your application, then your application is linearly scalable. What this means is that let's say if you have an ASP.NET application, you probably have a load balancer in front. If you have 4 servers, if you add a 5th one, you'll get another 50% or 20% increase in capacity. If that is the case, then you have a linearly scalable application. If not, then you don't have a linearly scalable application, which is what we're talking. I mean, that's the purpose of this talk, is that many applications are not linearly scalable. And when you start to put more load into them after a certain point, it doesn't matter whether you add more servers or not. They're just not going to scale. And the really bad thing about this is that you need this scalability when your business is doing a lot of activity, a lot of customers are coming to your website. Maybe you're an airline that just did a special promotion to Hawaii, and everybody's checking in for flights. They're going to do flight search and they're going to buy, and suddenly the website starts to slow down, maybe even crashes. Not a pretty sight. So again, you don't want to see this type of picture. Which applications need scalability? These are usually server-side applications or server applications. ASP.NET, web services, the backend for IoT is also usually web services. Big data processing. Big data processing is not that common in .NET. It's more of a Java domain, but the nature of the problem is still the same. If you're doing big data processing, you need to scale. You need to be able to process a lot of data in a limited amount of time. And any other server application, you may be a bank and you have millions of customers. They call and they want to change their address, or they want to transfer funds, or whatever else. Maybe they want a new card issued. And you have some compliance issues. You need to process all those things within a certain period of time. For example, if you need to transfer funds, you know that you have to do it within a certain time. And the more customers you have, the more scalability your application needs in that. Otherwise, you will not be able to meet your business needs. So if you have any of these applications, then this talk will be relevant for you. So where is the scalability problem? It is definitely not in the application tier. You can easily add more servers in the web application or the web services tier. You'll probably program your application in a way that these are very scalable. It's really the data storage, and when I say the word data storage, I mean relational databases, I mean legacy mainframe data. That's where the bottleneck comes. And again, I was just talking to somebody on Saturday. I was in Boston Code Camp where Jared was also there. So I was talking to this database guy, and he says, well, SQL Server is super fast. I said, well, I didn't say it's not super fast. So it's not about performance. It may be super fast, but if you have a web farm of 50 servers, you're not going to be able to handle that with one database server. I can guarantee you that. Most people don't have a web farm of 50 servers, but a lot of people have 4 to 8 to 10 servers. Between 4 to 12 seems to be the sweet spot that we see. And as you add more servers, database becomes a bottleneck. That's just the nature of the database. It's not any specific database. It's not a SQL Server or Oracle or DB2 or MySQL. It's, the nature is that a database is not distributed. It cannot process things in parallel over 4 or 5, 6 or 10 boxes. And that's why NoSQL database became popular. That's one of the reasons. There are also other reasons. We have a NoSQL database product that I mentioned. But a NoSQL database requires you to move data into that database away from relational. If you're not able to store data in a NoSQL database, it's no good, right? There's no benefit. And a lot of the time, you're not able to move away from relational databases for both technical and business reasons. And so, that's why this becomes a non-starter. A lot of people are using NoSQL now, but that's only for a subset of the data. They still have a combination of NoSQL database and relational. So with this picture in mind, you have to solve this problem with a relational database or with your legacy mainframe. That's the real challenge that you need to address. And that's where a distributed cache comes into play. Distributed cache, we've been in this space for the last 11 years now, and it used to be that whenever we would use the word distributed cache, people would just go blank about, they didn't have a clue what it is. But since then, Microsoft really adopted this concept. They came up with App Fabric, and App Fabric is going away. Now they've partnered with Redis because Redis supports all sorts of different languages. NCache has been around all this time, but now what we're seeing is a lot more people are aware of what distributed cache is. They still don't know details about it, about why to use it, where to use it, and how to use it. But if you keep that picture in mind, you can add more servers here. You cannot add more servers here unless it's a NoSQL database. So if that is the case, then you need to put a caching tier in between. And this caching tier is not high-end servers. These are inexpensive. These are like web server configurations. These are dual CPU, 8-core machines, just a lot of memory. And a minimum of 2 for redundancy purposes. And then after that, what we've seen is that a 4-to-1 or 5-to-1 ratio between the application tier and the caching tier is what works best. That's just a best practice that we've seen. A typical cache server here is just it's a VM or it's a physical box. It has about 16 to 32 gig of memory because it's an in-memory cache, so you need memory as your storage. It doesn't matter how much disk you have on this because you're not going to use it. It's memory, so 16 to 32 gig. We tell customers don't go above 64 gig. We do have customers that have 64, but we say instead of adding more memory than 64, just add another box. Because if you have, the more memory you have, the more .NET has to collect memory. And garbage collector is not a very fast activity. It's getting better, but it's, that's a drag. So if you have a lot of memory to collect, that needs a lot of processing power. And you're starting to become more and more like a database anyway, which is not the goal. The goal is not to have really high-end few boxes. The goal is to have a lot of very cheap boxes. so that you can scale. You can add more servers. A typical distributed cache like NCache, for example, would form a TCP cluster. So all these servers would become one logical cache or one logical capacity or one logical resource. So if you create a cache, that cache will span all these servers. Some of the data is going to sit here, some of it is here, some of it is going to be here. All that detail is usually hidden from you, but there's a distribution that is done by the cache. And if it's a good cache, for example, if you use Memcache, Memcache does not build a cluster. Redis does, NCache definitely does. If a cache does not build a cluster, then it's not really distributed. It's a patch-up work, even though Memcache was really popular. By having a cluster means that you can pool the resources. So what do you pool? You pool the memory, you pool the CPU, and you pool the network card. These are the three bottlenecks. When I say scalability bottleneck, it's memory, processing power, and network card. If you have large objects, if an average object is hundreds of K, you're going to very soon max out the network card. Well, maybe now it's a 10 gigabit, so it's going to take longer. It used to be 1 gigabit. But you still need more boxes to be able to do that. The same thing goes with memory. Because it's an in-memory store, it's a limited storage, so you need to add more servers. So the way this thing works is once you put this infrastructure into your environment, think of this as the new best practice. When you design your applications now, you've gotten accustomed to designing applications with databases. So now you need to become accustomed to designing applications with a distributed cache in the picture. And when you do that, this is a very powerful infrastructure that becomes part of your environment, and your application will never run into those types of problems that we talked about. Let's say you start out with a 2-server cluster, and as you add more and more load, you will add more servers here. Pretty soon you'll see these things maxed out, either from CPU or from memory. And when that happens, all you do is you add a third one here, or and a fourth one and a fifth one. So that's how it will linearly scale. And 80% of the time you'll be going to this caching tier, and 20% of the time you'll be hitting the database, mainly for updates, but also for some reads. And that's the goal that you should try to achieve. This picture is somewhat misleading because this assumes that you go to the database through the cache. That's only one paradigm. That's called the read-through paradigm. There's another paradigm where you go directly to the database like this. You get the data and you cache it. But next time, before you go to the database, you check the cache first, so that if it's in the cache, why go to the database? So, I hope I've made the case on why you need a distributed cache for a .NET application, actually for any application, but since .NET is the focus here. Once we've made the case on the fact that you need a cache, the first question that comes to mind is, well, what do you do? What do you do with a cache? How do you use it? Where in your application do you use it? What type of use cases fall under a distributed cache? So if you were to go back to your office tomorrow, and look at your application, you would know how to use a cache. The most common is the application data caching, which is what we just talked about, where there's a database, and you fetch the data, you put it in the cache, and the cache has it. There's a very peculiar problem with the application data caching that I want you to keep in mind as I continue in my talk. And that is that in an application data caching, the data now exists in two places. One is in the cache, and the other is in the database. So when that happens, what should you be concerned about when data exists in two places? Data consistency. Is the cache going to become stale? Is it going to become old? Am I going to withdraw those $1 million twice that I shouldn't be?
Persistence as well, and you lose the data.
Exactly. If you lose the data in this, it's not as bad of a problem because you can always fetch it from the database again. But if the data is old here and the data in the database becomes new, then you're forced to cache read-only data. In fact, most people, when you ask them, what do you use caching for? The knee-jerk answer is read-only data. People are really scared to cache those customers, those orders, those activities, the data that is changing every maybe 10, 20, 30 seconds because of this fear. So a good distributed cache needs to allow you to cache what I call transactional data. That's the updatable data, or the frequently changing data. Because if you can't cache that data, you're only caching maybe 10, 20% of your data. So the real benefit is not going to come from caching 10 to 20%. The real benefit is going to come when you cache all your data. Pretty much 90% of your data usage should have cache involved in it. So let's keep that in mind. Number 2 use case is ASP.NET applications. A lot of people know that the sessions, the storage option that Microsoft gives you is either in proc or SQL Server. There's also a state server on an on-prem situation which has gone away in the cloud. But both of those options have a lot of performance and scalability problems. So a distributed cache is an ideal case for storing your sessions. SQL Server or any relational database, when you store sessions in it, they're stored as blobs. And relational databases were not designed for blob storage. Whereas a distributed cache is a key value pair. Every value is a blob. So it's really ideal for a session storage. The second example of ASP.NET is if your application does not use the MVC framework, which a lot of existing applications don't, then there's this thing called a view state, which is an encrypted string that gets sent by the web server to the browser only to come back. So it takes a really long trip. It could be a pretty heavy string. It could be hundreds of kilobytes of string per request, and multiply that by millions of requests that you're going to process. Performance goes down because a lot more data has to travel, and bandwidth consumption. So when you host your application, you're paying for bandwidth. So it increases your operational cost if you have a view state going. And that's an ideal case for caching. So it's better to cache that view state and only send a small key. And the next time, instead of bringing the view state back, the key comes back and the view state is fetched from the cache. The third is the output cache, which actually Microsoft ASP.NET has a framework called output cache framework, which caches the page output if it doesn't change. Either the entire page or part of the page can be cached. By default, Microsoft caches it in an in-proc mode, which is limiting. You want to cache it in a distributed cache. These 3 examples, the nature of the problem completely changes from the application data caching. And the nature of the problem is that you are now storing this data, which is transient data, temporary data, but as long as you need it, you're storing it in the cache. So the cache is your master store. So when you have an in-memory master store, what could go wrong? Data loss. Because memory is volatile, so if any cache server goes down, you're that airline and a customer has just done all sorts of flight research and they're just about to place that $2,000, $3,000 order for their family, and suddenly their session is gone because the server crashed. So to solve that problem, you must provide replication. A good distributed cache must provide replication of that data so that any session or any of that data must exist on at least 2 servers. Because if it doesn't exist on 2, then you'll have that problem. And the third use case is a runtime data sharing through events, where you actually see this cache cluster as more like a message bus. Instead of using message queues, which have their own purpose, this is not trying to compete with message queues. You actually use this because it's much simpler to use. You already have this as part of your infrastructure now. It's a key value pair, and it has some event driven pub-sub type of a data sharing features. And through events, one application can put data into the cache, fire off an event. Other applications who are consumers of that data will receive that event and will go and collect it from the cache in an asynchronous fashion. So very, very powerful feature that a lot of people don't know about. And it's much faster and more scalable because of all of the other things I talked about. So those are the 3 high-level use cases of a distributed cache. Any questions before I go into more details? Okay.
Number 3 is like CQRS, right? Number 3 is like CQRS traffic. Command query responsibility.
Yeah. In number 3, basically, it's an event. So the application fires an event, or the event is automatically created. Let's say you say, I'm interested, if this data changes, please notify me. Or in case of a continuous query, you can actually specify an SQL-based data set and say, for example, select customers where customer.city equals New York. So you'll say, if any customer object with this criteria is added, updated, or deleted from the cache, please notify me. And so again, you're monitoring the cache. So you're actually asking the cache to monitor the data set and then notify you so that your application can take a corrective action. It's those types of things. So pub sub is where the application fires the event and says, I've produced this data. Go and consume it. And that event has the information about what that data is, so the consumers can actually go ahead and consume it. Okay.
Just a question is that why would you use distributed cache over just a queue? Why would you use this over message queue?
Well, first of all, if you have this cache in place already for application data caching, for ASP.NET, you have the infrastructure already there. So why not take advantage of it? That's one reason. Second is, it's actually faster and more scalable. Because of this scalability thing, if you have a high traffic environment, again, keep in mind, if you don't have a high traffic environment, you have a lot of options. And message queues actually offer you more features than a distributed cache when it comes to the messaging part of it. Although even a product like NCache is pretty close to a message queue in its features. But the purpose is not to be equal to them. The real benefit is the scalability. That you can really, if you have a high traffic application, nothing should affect the performance. As they say, the strength of any chain is only as strong as its weakest link. So if anything can cause scalability issues, then your application will overall slow down. So if you're doing a lot of updates, you're firing a lot of events, and the message queue is just piling up all those events and they're not getting delivered fast enough, then you will have performance and scalability issues. So a distributed cache has gained popularity because of that reason. So what happened actually is that initially only key-based events existed. And I'm talking from an NCache perspective, also from the Java side. By the way, NCache is the oldest cache on the .NET, but some of the Java players have existed longer than NCache. So, but this caching space, which the Java people call in-memory data grid, evolved in this fashion. That they saw that, okay, they started out with just a key-based event. They said, okay, if this item is updated, please notify me. Then they evolved this into, okay, well, if I can get these events really fast, why not add this concept of pub sub? So let's add this concept of a topic that I can then show interest in a certain topic, and then the producer of that topic will send a message that will be consumed by either one or multiple recipients. Then there's the continuous query concept came, where you said, okay, well, I have a lot of data, so I'm not just sending messages. I also want to monitor data. This is something that message queues don't have, because they don't have data. They only have messages. So you have to create all the messages. Whereas in this case, you can actually tell the cache to monitor data set and notify you if something happens to that data set. So I think the overall nature of the problem has overlap to the message queues, but it's also more data-focused events as compared to just the messages. Good question, though. Any other question on this? Okay. So let's first quickly get the ASP.NET specific example understood, because this gives you the biggest gain in the fastest way possible. Before I even go into that, I want to show you what a cache looks like. I'm going to, of course, use NCache, but my goal is to just talk about the cache overall. So let's say that, oops, I'm going to have a 2-node cache cluster. I'll have one client, and the word client here means your application server box. I want to create that and see how does that look like. So I have this some VMs in Azure. So I've got demo 1 and demo 2. These are my 2 cache server VMs, and demo client is my application server box. So I'm going to create a 2-node cache cluster on these two, and I'll just create one cache on it. In case of NCache, you can have multiple caches on the same VMs. So I will log into the demo client, and I'll use this tool called NCache Manager. So, and I think I have it here already. No, I don't. Okay. NCache Manager. I'm going to go ahead and say create a new clustered cache. So again, it's an Explorer style interface. All caches are named in NCache. So every time you create a cache, it has to have a name. So I just called mine demo cache. And I will pick a storage. It's called a caching topology. It's my storage / replication. I'm not going to go into the details of it, but I'll just pick a partition replica topology, which means the cache is partitioned and every partition is backed up onto a different server. And I will just go ahead and pick my first cache server. I'll pick my second cache server. I'll specify how much memory I want to allocate to this. In your case, it's going to be a lot more than this. I just have, let's say, 1 gig here. And then once the cache has used that much memory, then the cache will be considered full. So I will say, please evict 5% of the cache based on a least recently used algorithm. So I'm just going to say this. And I will now go ahead and add a client, which is my application server. And I'll go ahead and start the cache. Come on. Okay. I'll do some perfmon counters on this. Also launch the monitor cluster. And I'm going to actually run this tool called stress test tool. And that tool kind of simulates what your application will do to the cache. It'll do some reads and writes for you so that you can see what it is. Now see that you got about 1,000 requests per second per server. Let me start one more instance of this. And you'll suddenly see that this capacity will almost double. So you can add more and more of these, and then it's going to double. So this is what a cache looks like. And in case of NCache, you can also do other types of monitoring. But let's say here's what a cache looks like. So you're doing a lot of activities. When you start to max out these 2 nodes, all you do is you come here and you say add another node. I don't have another one, but if I did, then I would just add one, and then it would become a 3-node cluster at runtime. So keep this in mind as we talk about the further concepts. So let's say that if I want to use a distributed cache for ASP.NET session state storage, all I have to do is go to my ASP.NET application, and I have one here. So let's say I've got an ASP.NET application. I will open the web.config, and this is the same regardless of which cache you're using. So it's just that simple. You would go ahead and add an assembly. In case of NCache, you just add the assembly that implements the the session state provider interface of ASP.NET Framework. Once you've done that, then the next thing that you need to do is just go ahead and add this tag called session state tag and make sure that the mode is custom. Custom means use a third-party storage instead of in-proc or state server or SQL. And when you've done the custom, make sure you've got the correct timeout based on your application needs. And in case of NCache, the only thing that you need to do now is specify cache name. I mean, there are also other flags that I'm not going to talk about. But as soon as you make that change, so you created a 2-node cluster, you installed, and you configured all your application servers, and then you went and updated the web.config, and you reran the ASP.NET application. Suddenly, all your sessions are being stored in the cache. You'll immediately see a performance boost because it's all in memory, much faster than SQL Server storage. And it's going to suddenly there will no longer be a scalability bottleneck when it comes to session storage. So it's that easy to create a cache cluster and have to start to use it. Of course, you'll do some testing on it before you take it to production. But in terms of your effort, there's no programming effort really needed to use a distributed cache for sessions.
If I'm using it for session state, would I probably just stick it right on my web servers in that case then?
Depends how many web servers you have, because what we tell customers, I mean, let's say in case of NCache can live here. There's no problem. But it's not a very clean deployment picture, because what you want actually is you want the web servers to become stateless. And when they're stateless, you can bring any of them down for maintenance without stopping anything, without losing any sessions. If you're storing sessions in these web server boxes, you can't really bring them down if you need to do a bug fix or apply a patch. But when you have a redundant caching tier, the caching tier itself does not need to be updated as frequently as your application tier would be, because you're probably adding more features or fixing bugs to your application much more frequently than you'll get updates from NCache or from your cache.
Doesn't NCache sort of solve that problem for me? Because if I have all the web servers or all also NCache cluster members, I can bring down one, and I didn't actually lose any information.
You're right. Okay. Yes. If you had, let's say, a 3-node web farm, 3 or more nodes, then you can bring any one of them down, and you won't lose. Actually, even if you have 2 nodes, you can bring one of them down, and NCache will do that for you. It's still not as clean of a deployment strategy as having a separate caching tier. So we always recommend, if you have 3 or more servers here, have a separate caching tier.
The program that you have used for the configuration, the cache service, is it important which server hosts this application? I mean, is it on your local machine and you just say run the cache server on the IP addresses, or it's important to be somewhere?
All you specify is the cache name. In case of NCache, you know the cache based on a cache name. Your application does not ever deal with cache server IP addresses.
I mean the application that you have used for the configuration.
You mean that one?
Yes. And does it start a service on each cache server?
Yes. Good question. So yes, each cache server, when you install, let's say in case of NCache, when you install the cache software on your cache server VMs, a cache service process is automatically started. That cache service, it used to be that we would host all the caches within the same cache service process, and we re-architected NCache, so the cache service process is only for management. And every cache that you start, so let's say this is a cache here. I could go and add another cache. In fact, I was just having a conversation with you that a typical customer creates 3 caches. One for sessions, so they actually call it session cache. One for application data caching, which is some people just call it object cache. And one for reference data. So they just call it reference cache. So those are 3 caches on the same servers. 3 caches is what the common practice is. And the reason they do 3 is because, for example, and I'll talk about a few more features, is that they get more flexibility on how the nature of the use of each cache is different. For example, reference cache is a lot of reads but not a lot of updates. Session cache, there's equal number of reads and updates. Object cache, there's a lot more reads than updates, but there's still a lot more updates than the reference cache. So that's why people would usually create 3 caches. And so when you install NCache, there's a Windows service that gets installed and that gets run automatically. And this tool, NCache Manager, talks to that Windows service and says, please create a cache. So the creation of the cache is done through that Windows service, and that information is all kept in the configuration file. It's replicated to all the servers. Well, when you start the cache, I came here and I said start, right? So I said start here, right? When you start the cache, this NCache Manager tool now talks to all the Windows services and says, please start the cache on your server. So a lot of work is done at that time, which is hidden from you, and that's why it took some time when I started. And that work basically is that Windows service starts a separate cache process for every cache, so it's going to be a separate process. And now that process has to form a cluster with the other cache server processes on other servers. In this case, you only had 2, but if you had 3 or 4 or 5. And that cluster is a dynamic cluster that it goes through some handshaking and stuff. So that's why all of that is done. The client portion does not need to have a Windows service other than for management purposes. So if I want to add this as a client, and this NCache Manager will talk to a service process on that box to go and add this. But I will probably not host the cache in this unless I'm using this feature called client cache, which I'll come to. But good question. And you also...
So I was going to ask, at the NCache level, if you've got a cluster of, say, 5, how redundant is it, like if you need to take a node down? Or 2 questions. What if one node loses power, so it's unexpected? Or secondly, if I have a planned outage, can that node level, cache level continue uninterrupted?
Okay. So here's how that partition, when I picked the caching topology and I said there's a partition replica topology, that's what it looks like. So let's say if I had a 3 server cluster, every server would have a partition which is active. So all the partitions are active. So let's say in case of NCache, we have 1,000 buckets per cluster or per cache. So each server would have 1/3 the number of buckets. And then every partition is backed up onto a different server. And that's all done automatically. You don't ever get involved in it. The replica is passive. So the only thing that talks to the replica is the partition. And so let's say you come here and let's say that your application is here. The application actually connects to all the cache servers, so it can directly go where the data is or where it should be. So it doesn't have to go through multiple hops. So let's say this application talks to partition number 2 and updates or adds item number 3. When that item is added, partition 2 goes and talks to replica 2 and adds item number 3. Now, the replication could be done asynchronously or synchronously. That depends on your preference. By default, it's async, because the distributed cache usually works on an eventual consistency model. But NCache has the synchronous model because a lot of our customers are financial services, they're banks, they're trading companies. And when they're storing financial data in this, they're not satisfied with eventual consistency. So they will. So when they update this item number 3, the operation will wait until this is also updated. So that's the synchronous update model. So in this picture, when you have a 3-node cluster, and let's say server 3 goes down, what happens? Partition 3 is lost, right? So now replica 3, which is right here, becomes active. So it immediately becomes partition 3 for all practical purposes. So your application doesn't feel anything. Your application is continuing to do the thing. There are some operations that might fail that were like halfway, or that had passed a certain point. If they had not passed a certain point, in case of NCache will automatically retry them. But this will become active, and now it needs to merge itself with these two partitions because there are only two servers left, and two servers means only two partitions. So this will go away. It'll go into this and this, and now a replica for partition 2 is going to be created. All of that is done immediately after this server goes down, and that's what we call a state transfer. Or it's self-healing. It's automatically readjusting the data. At the end of it, you will be left with this. So the state transfer might take only 30 seconds. It might take half an hour. That depends on how much data you have. Because we don't want to overwhelm the entire cache with just state transfer, because the cache is still live. I mean, the applications are still doing all the activities. You will see some performance hit, of course, because the capacity has just dropped. But at least everything will continue to work. Did that answer your question?
Yeah. And I assume, like, for this example, like, I mean, the more you add, the more repetition or redundancy is added in the system.
Actually, we have chosen intentionally not to have more than 2 copies. Because more.
What I mean is, even with 2 copies, if you've got 5 nodes, one goes down and you're not having to replicate as much.
Exactly. So the more nodes you have, the less is the partition of the total. So it's 1/5 instead of 1/3. And the same way, you start out with 2 and you may add a 3rd node because you've maxed out those 2 nodes. And now you want to add a 3rd node. By adding a 3rd node means what? You're adding a partition will be created at runtime. Some of the buckets from these 2 partitions will be allocated to partition 3. Again, all done at runtime while the cache is working, the reads and writes are happening. And partition 3 will, once this data is moved, then partition 3 will now create a replica, and here and then this here. And it's done more intelligently, so whatever data was already there is kept. But you can add a server and you can go from here to here at runtime, and you can drop a server and you can go from here to here at runtime, and it's all done automatically. So behind the covers, it's a lot of complexity because of the fact that it's a distributed cache, and because it has to be highly available cache. One of the things I was going to talk about at the end of this talk, and now that you've talked about this, I'll just briefly mention, is that a cache is like a database. And for some data, it's your master store. So you need high availability. You need 100% uptime. Many of our customers have been using NCache for years, and they may have a scheduled maintenance, I don't know, very infrequently. Many of our customers don't even upgrade because they don't want to, interfere. In case of NCache, we're starting to have a more live upgrade path. I mean, high availability is very, very critical in case of a cache.
So the number 2 bullet right there. So if I was doing like an A/B deployment and I wanted to bring half the site down and split my cache or something like that, if I plan it, if I tell it I'm taking these 5 out of my 10 cache, will it slowly move the 5 over to the 5 that are staying active so I don't lose anything?
Exactly. That's exactly what that means. Okay. Is that you can stop any of the nodes. Okay. And then they're done in a graceful manner, which means all the data, that readjustment, let's say that you had a 3-node cluster and you actually did a scheduled stop. It's not a crash. You actually said stop this node. And it's going to be done gracefully, and all that stuff that I just talked about is going to happen before it is considered down.
But now if I have a lot of RAM on the servers and I'm using a lot of my cache, could that take a minute? Should I plan a length of time, 30 minutes or something, for it to maybe get them all synced up or whatever?
It depends how much data you have. If you have 100 gig of data, you're not going to transfer it in 2 minutes. But it moves pretty fast. It's all in memory, and it's done in a bulk fashion. Any other questions on this?
You said that the clients talk directly to the different caches. How do they know the state of the cache cluster? So if one node goes down, how do they know, and how do they know where the partition goes?
Okay. Good, very good question. So in case of NCache, the way NCache manages high availability is number one through this thing called dynamic cache cluster. So NCache has a peer-to-peer cluster. That means every node is a peer. There's no master slave in terms of the node. The configuration of the cluster, the membership of the cluster is all dynamic. It's all at runtime. Even though we put it in the configuration file, that's only a starting point. The actual information is obtained at runtime. So the clients, once a client connects to any one server, the first thing it receives is the cluster membership. Then it knows to connect to all of them in case of, it receives the cluster membership, and it also receives the topology. So if the topology was partition or partition replica, now it knows that it needs to connect to all of them right here. So it will go through the membership list and it will connect to each and every server. The next thing that it needs is to know where the data is, because it's not efficient to go to server 1 and say, please go and talk to other servers to get me that data. That's not a scalable model. It's much better for the client to go directly where the data is. And for the client to know that, in case of NCache, there's a distribution map that is also created at runtime. That's like a hash map value ranges. So from A to F, it goes here, stuff like that. The distribution map does not change when you're adding data. It only changes when you add or remove nodes. So when the membership changes, that's when the mapping about how many buckets were which node had which buckets, that's what changes. But the client will use the distribution map to know exactly where to go. So that's how the client would handle that. Again, all of that is done at runtime. Okay. Let me just go back to the okay. Now let's come to the application data caching. In case of .NET applications, most likely you will have to program to use a distributed cache. In case of NCache, it's a very simple API. The reason you have to program is because the .NET framework itself does not have a cache. For example, Entity Framework until EF Core. EF Core now has this, but prior to EF Core, there was no mechanism for the cache to plug in. Wherever the cache can plug in is, let's say, ASP.NET sessions, view state, output cache. That's where the cache plugs in. No programming needed. But what if you're doing object caching? What if you're trying to cache application data? You have to do API calls. In case of EF Core, there's a pluggable architecture where a cache like NCache will just plug in. And you don't have to do any programming. But even there, that it's a least common denominator approach, because that plugin has to be, it can't do more than just simple get and put. If you want to go into any of the advanced features, which I'll talk about why you need them, then you need to make your own API calls. So anyway, the API looks very straightforward. You connect to the cache based on the name. In case of NCache, you get a cache handle. You keep that cache handle, and you use it to do cache.get, get contains, add, insert, remove. Add has all of these have an async version. Async means don't wait for the cache to be updated, just give the control back. And there's a callback that you can specify, which I didn't mention, which gets called when the operation completes, or when there's a failure, if there's a failure.
Is there async for get also?
There's no async for get. Get is, you block.
Question, you pass a cache name. How does a client know how to resolve the cache name to the actual IP address or DNS?
Okay. So in case of NCache, let me just come here. So this box is my demo client box. So this is my demo client. So this is my application server box. When I create that cache, there's a config that gets created in NCache. And in this config, your cache name gets added. Can you see that here? Hold on. Here. So based on this cache name, it says these two servers are hosting that cache. And as I mentioned in this earlier question, that's just a starting point. Once you connect to any one of those servers, you actually then obtain the membership list, you being the NCache client. So NCache client will go to the client config file and get this first IP address and try to connect to it. If it can't, it'll go to the next one. If it can, it'll go through the whole list. It needs to be able to connect to any one of them. Once it connects to any one of them, in case of NCache, it will immediately then receive all the server names in the cluster. Because you might have added a new server at runtime, and you're not going to go and update the config files, or at least you shouldn't have to go and update the config files if you just added a new server at runtime because you've just reached your capacity. I mean, adding something to your config means some sort of interruption, right? Because you're restarting the whole application. But in case of NCache, you don't have to do that. So when you add a new server, an updated membership list is propagated to the clients, and the clients will connect to it and all the other stuff. But here, that's how this name gets resolved into connection to the cache server. And depending on the cache topology, this could mean that this cache handle is now connected to 3 cache servers or 4 of them, and your application doesn't know.
So essentially, your client also runs NCache process that connects with the NCache servers.
It has the client library, just the DLL. It also has the process, but you'll need the process only if you want to host some of the cache on the client box. I'll talk about that in a bit. But if you don't want to host any of that, then you only need the library, just the API. And actually, let me show you. So, for example, if I were to go and this, so I've got this really simple console application. I will reference 2 of the NCache assemblies here, ncache.runtime and ncache.web. So those are my client API assemblies. Once I reference those in my application, they're in GAC, or they could also be part of your application deployment, so they don't have to be in GAC. Then I will use the namespace for NCache, and by doing this, now I can make this call. And I've got the cache handle here.
So where is the config for the NCache? So like you're saying, if it's just a library, the DLL that's been referenced, you were showing that the config lives under program files NCache. So you still need to install it.
Yeah. So most of the time you do need to install the client portion of NCache. So when you install NCache, there's a server portion and there's a client portion. The client portion, we also have a version of it which doesn't install the service process, because you don't need it. Maybe but the default installation will install the client portion of NCache, including the service process, which you will not use most of the time, but the config and all of that will exist on your box. And not only that it'll exist, but when you go and use this tool, NCache Manager here, I actually went and I added a client node here, right? So by adding it, NCache Manager now goes to that client box, which actually in this case is just the same box, and updates the client config with this cache information. So in NCache, everything is based on a cache name. And even if you did not go through this proper installation, there's an option where you can keep the config within the application folder itself so that it can be deployed. But you need the config. You can there's an overload of initialized cache. For example, here I can say cache equals ncache.initialize cache, and I can get my overload to get this init params, where I can pass a lot of that information programmatically also. But that's not the default behavior that you'll pick. Most people don't go through that. Most people just take the config option. Okay, so after I have made the cache handle, I'm going to go ahead and create some object and do cache.add. I'll specify key. This is not a very good key, but your key should be more meaningful. And my object, my value. And in this case, I'm also specifying expiration. So let me now come to that topic, which is, if you want to do application data caching, there are a few things that you need to keep in mind, which are very important. How much time do we have?
You keep going.
Okay.
They'll start leaving if they get tired.
Okay. I don't. Well, there's a VR headset, so maybe they'll stay. So. By the way, I think we should pass this around. So for those of you who didn't fill this in, maybe you can do that while I'm talking. What are the things that you need to be concerned about? We talked about the fact that when you do application data caching, the data exists in two places. So a cache must synchronize, or the cache must ensure that it is fresh. How does a cache ensure that it's fresh? So that's the first topic in application data caching. How do you keep the cache fresh? This is a very important thing that you need to keep in mind if you're going to do application data caching. Number one is something that everybody has. It's called expirations. I just showed you this code. I'm specifying a 1 minute absolute expiration. So I'm saying don't do any sliding expiration, but do a one minute of absolute expiration through this calendar object, this datetime object. What does that do? It says to the cache, I feel comfortable keeping this data in the cache for that long, let's say 1 minute. After 1 minute, please go ahead and remove it from the cache. Because if it stayed in the cache, I'm afraid it's going to be changed in the database and it may go stale. So you're making an educated guess in case of expiration about how long the item should stay in the cache. There's another expiration called sliding expiration, whose purpose is totally different. It has nothing to do with keeping the cache fresh. That is if you want to clean up the cache when that data is no longer needed. For example, sessions. So you specify a 20-minute sliding expiration and say, if nobody touches this session for 20 minutes, just clean it up. It has nothing to do with keeping the cache fresh. It has to do with more of not, so that your application does not have to keep track of what is kept and what's not. So this is the first feature that you have. But what if you cannot make that guess? What if you have a database that has multiple applications updating the data? There may be even some admin ways of updating the data. Then your guess could be wrong. So that's where you need another feature called synchronize the cache with database, where the cache becomes a monitor of the database. So there's a feature in ADO.NET called SQL dependency, or SQL cache dependency. And that's also its variation called Oracle dependency, which uses SQL Server events. NCache uses that feature and lets you specify, when you add something, for example here, let me show you this here. So let's say that if you were adding some data to the cache, so I'm going to come here and say add product with the cache. So as I'm doing cache.add here, I've got the key, and instead of having the actual value object, I'm going to have a cache item. In the cache item, I will specify a SQL statement. I will actually create a SQL cache dependency, which is an NCache object, which takes a connection string to your SQL server, so it can connect to your SQL server, and it takes a SQL statement. This SQL statement results in some data set. It could be one row, it could be multiple rows. Usually it is one row because that's how you're doing it, but it could be multiple rows. And you're executing this code on this box here. So you make the NCache API call, and you're saying to NCache, please become a client of my database. Here's my connection string, and here's my SQL statement, and please monitor this data set. If that data set changes in the database, please invalidate the corresponding cached item. So now the cache go ahead. I think it does, yes, it does. But it does not work on a multi-table joins. And that's more of a SQL Server limitation than NCache. Because that SQL cache dependency is a SQL Server feature that NCache uses. So now the cache suddenly becomes aware of your database, it has become a client of your database, actually, because you've told it how to connect to your database. And now it is monitoring. If that data set changes, the database sends a notification. The cache invalidates the corresponding item. What is the benefit of invalidating? It's no longer in the cache, so your application will be forced to fetch it from the database. So database synchronization is a very, very powerful feature that ensures that you can actually start to cache that transactional data. And the more data you cache, the more benefit you have. If your database is not SQL Server or Oracle, then there's a feature called DB dependency, which is a polling-based feature that NCache has implemented that you can use. You can also use CLR procedures to actually directly update the cache from the database, if you wanted to do it that way. In case of NCache, if you did that, make sure that you make the async calls. That's why we have them, because a database transaction times out very quickly, and you're making a call to a cache cluster. Go ahead.
If you can go back to the SQL dependency example,
Uh-huh.
in this case, you have the query. Typically, people use stored procedures. So how does it work in this situation where you don't know what the query is? You call it stored procedure, and the query is within the underlying stored procedure.
I think as he asked the same question, I think it works with stored procedure, but I can confirm that I just don't remember on top of my head. But I think it works with stored procedure. It just does not work if you have multiple tables in a join.
Or if you have multiple queries within the stored procedure, because you don't know which query.
Yeah, I think even within a stored procedure, you have the same limitations, because SQL Server creates a data set within the database server that it monitors, so that if any row matching that criteria is added, updated, or deleted, it notifies you. Or in this case, it is if it's updated or deleted.
And probably that's where the polling comes into the picture, where you're not sure.
Yeah. So if you don't want to use this feature, let's say that your situation is more complex, then you can do a polling-based thing. And even if that is not sufficient, then you can actually do a CLR stored procedure, call it from within a database trigger. Let's say if as soon as a row is added to a table, a trigger calls your stored procedure. Your stored procedure constructs an object, puts it in the cache. So with a stored procedure, you have the added benefit that you can also add data as it is being added to the database. You can add it to the cache also, which you cannot do with these. This only works for updates and deletes.
The SQL dependency, as I remember, and I was peeking at it real quick, it has a pretty long list of limitations in what can be in the SQL statements. You can't use you can't use unions, you can't use intersects, you can't use joins, you can't. I've struggled to get a query that's useful other than maybe for a lookup table. I thought also with SQL dependency, when I played with that in the past, don't you eventually, I didn't think you wanted too many subscriptions. I felt like that I decided I was going to be great and I was going to just stick my whole database in the cache. And
very good question.
SQL said, forget it, man. I can't monitor all that.
Very good question. I was just going to come to that. That SQL dependency has limitations. If you have 1 million SQL dependencies, I can guarantee you SQL Server is going to die. So it has benefits. In some cases, it is event-driven. It is real-time. DB dependency is actually more efficient, although it will run every 15 seconds. But in one fetch, it can update thousands of rows, which you will need thousands of events from SQL dependency. And CLR procedure is even more efficient, where there's no limitation to how much data you have. You're just calling, the cache, and as long as you make the async calls, the calls are super fast.
So when you say CLR stored procedures, are we using the SQL CLR?
That's what I was thinking too. You're using .NET inside of that, right? You're using .NET inside of that.
Yes, exactly. So within the CLR procedure, you convert your data into a .NET object, whatever your application is using, because what you are doing is putting data in the cache that your application will consume. Because the cache is being used by this, right? So whatever you've got here, whatever you put here has to be in that same object that the application will use. So yes, so you do need to create the same objects, and you should make the async calls so that your database transactions won't start to time out. Any questions on this? Good questions, by the way. Okay. So let's say that in case of expiration, in case of database synchronization, the way I'm keeping my cache fresh is by removing that item from the cache. What if I need that item and I'm just going to come and re-add it again? And my application is really high traffic, so as soon as I remove it, I'm going to have hundreds, if not thousands, of requests coming for that same item, and they'll all go to the database now. And I have hundreds of thousands of these items, they keep expiring, so my database is constantly being hit by these unnecessary reads. How do I avoid that? Because they'll all read and they'll all update the cache. So that's, except for the first one, all the other ones are unnecessary, but since they started when the cache did not have the data, they'll all have to go to the database and they'll all have to fetch that object and add it to the cache. What if you could actually, instead of removing these, you could just update. You could just have the cache load the data from the database and just update. You can do that if you have a read-through concept. Read-through is a very powerful feature that NCache has. A lot of the Java caches also have, but on the .NET side, only NCache has it. And a read-through is essentially your code. Let me show you what a read-through looks like. So again, you have the same application. You link with the NCache assemblies, and you implement this iReadThrough provider interface of NCache. It has three methods basically. There's an init, where you connect to your database or your data source. It has a dispose, which you disconnect. So init is called when the cache starts. Dispose is called when the cache stops. And after that, there's just a load from source. It gives you a key, and based on that key, you're supposed to figure out how to go and fetch that data from your data source. And of course, you will then create that object, put it in a structure that has a lot of other metadata like expiration information, all sorts of, and you pass it back to the cache. And the cache then caches that object. So when NCache calls the read-through, NCache is able to go and get that data from your database, put it in the cache. So where is read-through used? I mean, why do you use the read-through? One benefit is, oops, hold on. One benefit of the read-through, and again, read-through is your code that runs on the cache cluster. So it's a server-side code. If you were to use, for example, Redis, it's a cache as a service. So you have no access to the cache servers. You can't have features like read-through. NCache or Java caches would give you that facility. But it's a really powerful feature. On the Java side, it's part of the cache standard now. On the .NET side, since there's no cache standard yet, so NCache is the only one that provides it. But a read-through runs on your cache servers, and you can use read-through for two reasons. One, let's say your application does a cache.get right here. You do a cache.get, and this object is not in the cache. You can tell NCache and say, if it is not in the cache, go and read it from the read-through. Or you can tell NCache, well, don't use the read-through. If it's not in the cache, I want to have a miss, so I can do whatever I want. But let's say if you wanted NCache to go and read it, the NCache will go ahead and call your read-through handler, which will get the data and all the other metadata, expiration, and all the other stuff. It'll put that object in the cache, and it'll give it back to you right here. So the next time you do a cache.get, that object is in the cache. So the net effect is the cache always has the data. Whether cache gets it from the database or not, that's just when it is. So that's the first use. Second is when you have expiration or database synchronization, instead of removing, you have this feature called auto reload. Right here. So you can configure NCache and say, when this item expires, don't remove it, just reload it. Because I know it's going to be reloaded anyway, so might as well reload it yourself. And that way, that item will always be in the cache. It just gets updated. At time ti or tk, whatever, that thing gets updated. So prior to that time, it had the old value. After that time, it had the new value. So your application always has the data, or always sees that item in the cache. So really powerful concept. Similarly, there's a write-through, which when there's a read, there's also a write. So a write-through works exactly the same way. There's an interface that you implement. It has an init. It has a dispose, and now instead of saying load, it just says write. Now write could be add, update, or delete. So that information is kept here. So this object contains not only the actual data that it wants you to write, but also what is the operation type. Where is it? Yes.
Operation result.
Yes. So basically, based on what the operation is, it will go ahead and write the database. And there's also a bulk operation. The write behind has the same benefit as read through, which is that you can centralize all the write operations in the write through. But write through has a feature called write behind, which actually is a lot of, it boosts your performance, because all the database updates are not as fast as cache updates. Cache updates very fast because cache does not have to process all the queries and all the other stuff. It's just a key value pair. So why not update the cache immediately, but update the database in an asynchronous fashion? You don't have to do it for all data, but a lot of data where it's more of an eventual consistency model is okay. Write behind is very, very useful. You call the write behind, it gets queued up, the queue itself gets replicated in case of NCache, and the database gets updated. Suddenly, your writes are also much faster than they were before. So, go ahead.
No, I was going to say, but not really the database, because they have a second step. You're saying the writes are faster, but again...
I'm saying from your application's perspective,
correct, it is.
Yeah. It is.
You write directly
Yeah.
to cache.
Yeah. Exactly. So the application performance improves.
Is there a way to monitor the failed writes? Like in case the write fails for the database, can you, let's say, by the end of the day, have a list of failed writes, for example?
Yeah. Actually, so when a write fails, it will retry. If it's a write through, then your application is waiting for the write to complete. But if it's write behind, then if the write fails, it will retry. But if it fails, it will also notify the application that failed. Because whatever you're trying to write, your application must know whether the database was updated or not. So read through, write through, when especially read through when you combine it with these two, becomes really powerful. And then we've talked about the write through. So now we're able to keep the cache fresh. I'm coming to a close now. Now that we're keeping a cache fresh, so we're able to cache a lot of data. When you cache a lot of data, then cache is looking a lot more like a database. The more data you cache, the more type of data you're caching, the more you'd want to search the cache other than just key value. So cache.get is not sufficient anymore. So any cache that only provides you cache.get is not really preparing you to store all types of data in the cache. So what you want to do is to have other features. In case of NCache, there are some data grouping features that you can do: group, subgroup, tags, and name tags. These are a way of grouping data into some logical grouping. So then you can later on say, give me everything that belongs to this group, or give me everything that has these tags associated with it. And you can also say, delete everything in this group. You can also, that's one. Second, you should be able to search the cache like a database. So in case of NCache, it provides SQL searching. Again, Java caches do the same. I keep saying Java caches so that you don't think it's a promotion of NCache here. I'm just saying that a powerful cache provides this feature. On the .NET side, NCache is the only one that does, but on the Java side, other caches do it. So if you're able to search the cache based on attributes, so you can say stuff like select customers where customer.city equals New York. you'll be able to get a collection of all the customer objects back. You can also include in the search criteria the group and the tags and the name tags. So by having the ability to search the cache, of course, whatever you search, NCache requires you to index those attributes because the data is kept in a serialized form in the cache, so it's really very, very difficult to look it up once it's cached. At the time of adding it to the cache, that's when it is the metadata is extracted and then indices are created. So SQL-based searching is very, very powerful. And in case of NCache, then of course it's not just SQL; it's also a link. So, for example, where do I have it? Okay, hold on. Give me one sec. So I'm going to object query language. There. So, for example, in case of NCache, I can issue some sort of a SQL statement, and I can execute it. I can say cache.execute reader, and then I can iterate over that reader to go and get my data. So that really makes the cache very, very powerful. So you need to make sure that your cache can be kept fresh, that you have write-through features, and that you can also do grouping and searching of the cache. When you do that, then your cache becomes a very meaningful cache that you can use. I want to just cover this one last feature, and then we'll be done. We talked about the client, whether it should have a Windows service process or not. Well, there's a feature. Actually, let me step back. If you were using ASP.NET Cache object, the old inproc cache, many of our customers, when they moved to NCache, they immediately complained that their performance actually went down. They said, I was hoping to really improve my performance, and the performance actually went down. And then we have to then explain to them that the reason it went down is because now you're serializing the object and storing it in an out-of-process cache. The caching tier is right here, and your application is here. So, and previously your cache was right within your application process, kept in an object form on the heap. How can you match that performance? So they say, well, but I need that performance. I can't afford to not have that. So then we, that's where we have this feature called client cache. The Java side calls it near cache. This is a cache. It's a subset of this caching tier. So just like the caching tier is a subset of your database, the client cache is a subset of the caching tier. And in case of NCache, you just configure it. There's no programming needed to use the client cache. You make the standard cache API calls that we just saw here. Whether you use the client cache or not, it's the same. But once you plug in once you configure the client cache, then whatever you're fetching gets kept in the client cache. And this client cache could either be outproc, in which case you need that Windows service process on the client box. Because why do you need outproc? Because you might have 8 worker processes, and you don't want to have 8 copies of that data, because you've got 1 gig or 4 gig of data for the client cache. So multiply that by 8 is a lot of gigs per box. So it's better to keep it in the client as an outproc. That's still faster than going to the caching tier. Or if you don't have that problem, if you only have 1 worker process or maybe only a couple, go ahead.
But the moment you start using client cache, you don't have distributed caching, so you are using sticky sessions or sticky IP, and you're always going through that server, right?
No, actually, so that's what I wanted to explain. So once you enable the client cache, whatever you fetch from the clustered cache, from the caching tier, it is kept in the client cache. So it's another copy now. So it's a third copy actually, because you have 1 in the database, 1 in the caching tier, now third copy is in the client cache. And it can even be inproc. In case of NCache, if you configure inproc, the NCache will keep it in an object form. So that when you fetch it, you're actually fetching it like your inproc standalone cache. Of course, the first time you fetch it, it's not as fast. But the whole idea of a client cache is that you put that stuff in a more reference environment where you're doing a lot of reads and not as many updates. Go ahead.
Yeah, I was just going to ask really quick. So if you were going to do something like, let's say it was a car dealership, or let's say it was cars.com, would I use this for something like my car makes and models, things that aren't going to change that often, where I'm going to be using them continuously over and over and over again for everything? and then use your secondary caching or the normal standard caching for things like lookups for dealerships and things like that, that might be different or offset for, that kind of stuff, or the one-offs that you're not going to get everybody in Ackworth, Georgia, if that makes sense?
Very good question. I think definitely, so the reason I said our customers usually have 3 caches, because they always use client cache with the reference cache. Because the reference data is something that's going to change maybe once a day, once a week, something. So that always has the client cache. But whether the object cache, which is the transactional data, has the client cache or not depends on your application use case. If you have a use case where you're still reading a lot more than you're updating, then you should have a client cache also for the object cache. You should never have a client cache for the session cache, because the number of reads equals the number of writes. For every web request, there's 1 read and 1 write. At the beginning of the page execution, it goes and fetches the session, you do your thing, and page is done, it goes and writes the session back to the session store. So if you have 1 read and 1 write, or if the number of reads equals number of writes, in case of client cache, the write has to be done in 2 places now. So suddenly your performance actually will drop. So that's why we say create 3 caches, and then at least one of them will always need the client cache. The second one may or may not, and third one will never have a client cache. But a client cache gives you super fast performance, the same as inproc, but not with the limitations of inproc. None of that stickiness is needed anymore. Because let's say if you cache something here, next time your request comes here, well, you get it again, because it's always going to the caching tier. Now it's in 2 places. Let's say this third client goes and updates that data. Because this cache is kept synchronized with the clustered cache, in case of NCache, the caching tier knows that this data item is kept in these 2 client caches. So it notifies them immediately, so they'll go and update themselves. It's not done synchronously, it's eventual consistency model. But that's what happens whenever you do read-intensive operations, it's always eventual consistency model, because that's where you get the real benefit of performance. But a client cache is a really, really important feature, because it gives you the, that super fast, that 150,000 reads per second from a single application that you can never get through any outproc cache. Just to end this, I know people were asking me about NCache versus Redis. Microsoft picked Redis, as you know, for Azure. Redis has become really popular as a replacement of Memcache. That's how they made their name, because Memcache had a lot of limitations that Redis fixed. But Redis is a Linux-based cache. So when you go to the company that makes Redis, oops, hold on. Unless they've changed it now, hold on. The last time I was there, it was like this. I don't want to be caught with my pants down, so.
For Windows as well, but what I've heard is the Windows offerings for Redis is much buggier.
Actually, so what I was going to say is, if you were to come to their website, they've just changed it, and you go to the, say it again.
I said, too bad the page wasn't in your cache.
You're right. If you go to the download page, the only options they give you are Linux. Microsoft ported them to Windows, but Microsoft is not even using that port themselves. If you go to Azure and use the Redis service, they're actually using the Linux version. That is the official Redis from Redis Labs, because that's the only stable version. A lot of customers have complained to us. We've done our own testing also. We can't say it in a marketing brochure, but the reality is that it's not as stable. If you go with the Linux one, it's very stable. But the comparison, and people ask for comparison. So from a comparison perspective, what happened? So NCache is also open source. If you don't have the money, it's an Apache 2.0 license, so just go and download it either from our website or from GitHub, and it's all free. There are no limitations built into it other than some features. So there's no cache size limitation or the number of nodes limitation in the open source. There's an enterprise edition which has more features and comes with support. If your project is more business critical, then go with enterprise. In case of Redis, if you're on Azure, then you get Redis as a service where you don't get to see the server. You only see the client API. So all the other features we talked about, you don't get. Actually, they don't even have them. So even if you didn't have the service, you wouldn't be able to. But in case of NCache, it's available on Azure and Amazon. It's also on-prem. It is you actually get the VM, so you control everything.
Are you planning on having it as a service?
We actually don't intend to, because we've seen this space for a long time. We have a lot of customers, and a cache needs to be close to your application, and you need to really control your cache and be able to monitor it and be able to add more VMs if need be. To depend on somebody else may be okay for a small business that does not have the resources, but most of the customers who need scalability have a lot riding on it. So they need. None of our customers that we've talked, that we have and that we talk to would accept cache as a service, and our customers are some pretty brand name companies. So they want to control their own destiny instead of just have a black box. There's benefit to the black box being simplicity, but the downside is it's the same with SQL database. SQL database is a database as a service. The serious players don't like to go with SQL database. They go with SQL Server because that gives you all the control.
Last sales pitch for you, I guess. What is your support? Because 99% of the time when I get asked about doing caching or anything, this is the stuff that's going to die during the middle of production, and we need support right now. So
Yeah. Yes, we do. So if you buy the Enterprise Edition, of course, if it's open source, then it's as is, no support. But if you go with the Enterprise Edition, you get more features, but you get support, and you can also choose to get a 24/7 support.
So like telephone calls.
Yeah.
Like with that service bus, we had an issue where we were trying to do things on open forums, and that just didn't fly very well with a lot of the enterprise customers.
Yeah. So we have a full tech support team that works, and we have customers in the U.S. and we have customers in Europe, and 24/7. Of course, we don't want you to call us in the middle of the night for a quick question. So it has to be. Of course, yeah, of course. Yeah, just to give you an idea, these companies wouldn't even talk to us if we didn't have that type of support. NCache was launched in July of 2005. That's going to be 12 years in a few months. And we've learned a lot when we launched this. We didn't even have a clue that it would become such a main phenomena in the industry, because scalability is huge now. Everything is scalability. Everything is in-memory computing. And actually, the .NET side is lagging behind in all of this adoption. And we're focused completely on .NET, but we are, we come from a computer science background. All of us are nerds. Most of us who are over 40 started their education from Unix, so C, and then moved up. So there's a lot of awareness of what is happening on the Java side, and in NCache our goal is to make sure that we are as good as they are, but for .NET, and that's the model that has worked for us. NCache supports Java clients, so we do have customers who use it for Java, but I'll be very honest. Every customer that buys NCache buys it for .NET and then uses it for Java. There's not a single Java shop that will touch a .NET product. They just wouldn't do it. But if they purchase it for .NET, then they'll use it for Java also.
Now that EF Core is out, do you think are you targeting having a second level cache?
Yes, actually we are. So if I come to our website, where's the website? There. Actually, if you see, we've already launched the support for ASP.NET Core, and we're in the process of working on the EF Core. So we should have it pretty soon.
You think you'll have a full second level cache?
Yeah.
Hibernate yet?
Yeah, we've had an Hibernate second level cache, for the longest time.
You have
Yeah.
one now.
Yeah, so we have an Hibernate second level cache. We have a Hibernate second level cache from Java side, all on NCache. And we implemented our own. In fact, if I were to go to EF, let me just go to, now it's all about NCache. Now, if I were to go to EF, we've implemented our own custom ADO.NET provider, because EF6, up until EF6, there was not, including EF6, there was nothing to plug in a third-party cache. So we had a query level cache. So SQL statements were being cached, and there was so you could use it in an analysis mode first it'll just log all of your queries, and then you can see which ones you want to cache, which ones you don't want to cache, and then you could also do SQL dependency with them if you wanted to, because that was the only way to do it. It's not as powerful as entity level caching, which is what EF Core allows us to do. So we're going to be launching that pretty soon.
Very cool.
That's the end of my talk, guys. If anybody has not signed in to the list, we're going to do a draw, and I promise you won't get bombarded with any of the sales stuff. And we're going to do a draw based on Google random number generator. So if you guys see that list, every name has like a index number. So what's the largest index number there?
34.
37. Let's just do 50, okay? Just to have some fun with it. Okay, so I'm going to ask Jared to come and press the button, just to make it more neutral. Hold on. Let's just wait.
He's gonna, if you hit 20 something, he's gonna
So, and here's the actual VR headsets.
I'm pretty sure they're gonna find it out when they go. That's the unfortunate number. See, that's not going to come back. And I'm number 9.
No. I was just testing it.
Exactly. You know, you've wasted my opportunity.
No, I'm gonna start over again. No. I want to be totally fair. So I will do I'm going to do a.
Well, it doesn't matter. It's not going to come up. No ways.
Okay. Yeah, of course, as soon as I know what the max is. I don't want to be less than the max, because it's like in golf. Unless your ball crosses the hole, it's 100% failure, right? So. So, are we all done? Okay, let me have it so that we can. Okay. So basically, that's 1, 2, 3, 4. That's how the numbering is. 1, 2, 3, 4, 5, 6, like this. Okay. So I will press the button and then you read this. So what's the maximum?
Right, that's what I was asking. 41.
Okay. 42 is the maximum, let's just say. Actually, it's 41, but I'm just going to.
If it's 42, do you get to keep it?
No.
Oh, okay.
We will retry.
Okay.
Somebody has to win. Okay, guys. Where's the drum? There you go. Okay, there it goes.
9.
18.
Let's go.
Oh.
We'll get that in a second. 18 is Robin. Wife?